Hello students, good evening everyone. I hope all are doing well. Welcome to Infinity Learn by Sri Chaitanya. This is me Surya, your chemistry faculty from Infinity Learn. And I hope I am perfectly audible and visible to each and everyone present over here. So those who are watching the live, just mark your attendance. So in the last two classes, we have already seen the chemical bonding and the molecular structure chapter, right? We have already seen what you mean by the chemical bonding, what is the exact definition for the chemical bonding. Then we have seen the formation of covalent bond, right? In the case of chemical bonding, there will be two types of bonds are forming. One is the covalent bond and another one is the ionic bond. This covalent bond is formed by the sharing of electrons. There will be two types of, okay, hi, good evening. So there will be two types of bonds are present, right? In the case of covalent bond, there will be two types of bonds are already present, polar covalent bond and the, yes, I am already fine. So, in the case of polar covalent bond, there will be sharing happens, right? Polar covalent and the non-polar covalent bond is already present. So, in this class, we are going to discuss about these important topic about the ionic bond, how the ionic bond are forming, what are the properties of the ionic compounds, and what is the definition of ionic bond. Okay, I think we can start our session right now. So, what is the exact meaning of ionic bond? How these ionic bonds are forming, or how the ionic compounds are forming? We have already discussed, right? In the last class, we have just given a brief idea about the formation of ionic bond. So what is happening in the ionic compounds? Whether it is sharing of electrons happens or transfer of electrons happens. Okay, again, you can see over here, right? It is the electrostatic force of attraction. As we already know, chemical bonds are the electrostatic force of attraction between two oppositely charged ions, which is formed by the transfer of one or more electrons from one atom to another atom. That is called the ionic bond. Let us see in detail about the formation of ionic compounds. Okay, you are the students of class 11, right? Then it will be easy for you. We are just giving the introduction part for the chemical bonding, which we are going to discuss detail in the grade 11 class, right? Chemical bonding and molecular structure. That is a chapter 4. Okay, I hope you understand how the ionic bond is forming, right? It will be formed by the transfer of electrons between two atoms. In special, we can say that one will be metal and other one will be the non-metal. So this is a bond formed between one metal as well as one non-metal. Then here, this ionic bond is also known as the electrovalent bond. In the last class, we have already discussed about the covalent bond, right? Covalent bond is already known as the electron pair bond, right? In the case of ionic bond, they are known as the electrovalent bond. So this is the basic information or the basic definition about the ionic bond, how they are forming. Now let us see in detail by using the diagram of the formation of ionic compounds. So I hope you can see the image clearly here. This is our first atom. Especially it will be a metal, and this is the second atom. This is a non-metal, right? So what you are observing here, do you have any idea from the image? This is the one of the electron in the first metal, first atom of the metal, right? So the one electron from the metal is lost from the metal and it is gained by the second atom or the non-metal, right? I hope you are getting. So here, metal loses one electron. And the electron lost from the metal will be gained by the non-metal. Is that clear? This is the electron. It is gained by the second metal or the non-metal to form the ionic molecule. So those who are lost by the electrons will be getting the positive charge, and those who are gained by the electron will be getting the negative charge. So that they are forming the okay, fine. Okay, those who are lost by the electrons will be having the positive charge, and those who are having the gained by the electrons will be having a negative charge. So in the case of ionic compounds, there will be cations as well as anions present, right? So metal will be easily forming the cations and non-metal will be easily forming the anions. Clear? Hi Arush, good evening. Now we have just started just now only. We have just given the idea about how the ionic bond is forming. What is the exact definition for the ionic bond? So as we already know, ionic bond is formed by the transfer of electrons between a metal and non-metal, right? Metal will be easily losing the electron to form the positive ions, and non-metal will be easily gaining electrons to forming a negative ion. So in the case of ionic compounds, okay, in the case of ionic compounds, both cations as well as anions are present. So we will be giving an explanation by using a diagram, right? So is the formation of an ionic molecule. Now we have to see what is the condition or the formation, what is the condition for the formation of an ionic compound or ionic bond. Harish, did you study any other bonds other than ionic, covalent, metallic and coordinated bonds? So we will be mainly dealing with the covalent and ionic bond in the case of chemical bonding. Now let us see how the formation of ionic bond is forming, right? We have already seen the diagram here. They are just giving the explanation in terms of words, right? So an atom with a more electropositive character, right? Electropositive character means it has a tendency to lose electrons. That means they are already metal, right? So these metals are lost one or more electrons to form a cation. Cation means they are having the positive charge. Clear? So for example, if you are taking A as the metal, this A will be losing this one electron to form A plus. A plus means it is a cation. Then it will be attaining the nearest stable inert gas configuration. Let us see in detail about the formation of NaCl molecule. Okay, you can follow our channel. Manmohan, right? Yes. Classes are already recorded by us sir in our channel. Even Pratnam ma'am is also doing the classes for the maths for grade 10. Okay, I hope you understand the formation of the cations, right? Or the formation of ionic bonds in terms of cation, right? Now let us see how the electronegative element, right? So an atom with more electronegative character means they have the tendency to gain electrons. Those elements are known as the non-metal. So they gain one or more electrons to form the anion. Anion means they will be having the negative charge. Manmohan, just subscribe our channel, then you will get the notification for the maths classes. Okay, now you can see here, right? B will be the non-metal. This B will be accepting one electron to form the B minus ion, or B minus is known as the anion. So easily it will be also forming the nearest stable noble gas configuration. Okay, I hope you understand the formation of ionic bond, how they are forming the ionic bond, right? Metal will be losing electron, that electron will be gained by the non-metal to form the corresponding ionic compound. Then the cation and the anion, right? Cation is formed from the metal and anion is formed by the non-metal. They are combined together to form, okay, they are combined together to form a particular compound known as the AB compound or known as the ionic compound. Is that clear? Okay, is that clear how it is formed in ionic compound or the ionic bonds? The main point you have to keep in mind that whenever ionic bond is formed, it will be formed between metals and non-metals. Metals will be having the electropositive character, which means they will be losing electrons. Once they are losing the electron, they will be having the positive charge. Then especially these lost electrons were gained by the non-metals. They have the electronegative character. They will be gaining the electrons to form the negatively charged anions. So these cations and anions combine together to form the ionic compound. The same we will be explaining detail about the case of sodium chloride. Sodium chloride, as we already know, right, our common salt formed by the Na plus and Cl minus ion. So which is the metal here in case of NaCl, which is the metal and which is the non-metal? In the case of sodium chloride, as we already know, sodium is our metal and chlorine is our non-metal, right? So obviously metal will be losing electrons, right? So what will be the possibility here? Sodium, as we already know, atomic number is 11, right? Atomic number is 11. So if you are taking the substitute electronic configuration, it will be 1s2, 2s2, 2p6 and 3s1, which is already given here, right? 1s2, 2s2, 2p6, 3s1 will be the electronic configuration, substitute electronic configuration of the sodium. So what you are forming here, this sodium will be losing this 1 electron from the 3s orbital, right? It will be losing 1 electron to form the Na plus ion. Then what will be the electronic configuration? It will be 1s2, 2s2, 2p6, right? So this will be the electronic configuration of nearest to noble gas, that is neon. Is that clear? Yes, sodium is the metal and chlorine is the non-metal, right? So sodium will be losing 1 electron to form the sodium ion. So it will be having the electronic configuration as 1s2, 2s2, 2p6, which will be the nearest stable inert gas configuration or the noble gas configuration of neon. Is there any doubt? Then what will be the another possibility? These electrons are lost by the sodium atom, right? That electron will be gained by the chlorine, right? They will be gained by the chlorine. So what is the electronic configuration of chlorine? Atomic number is already 17, right? So 1s2, 2s2, 2p6, 3s2 and 3p5 is the 3p5 is the electronic configuration of chlorine with atomic number 17, right? So what is happening here? Here it will be, we need to get the complete electronic configuration of the nearest stable gas, right? So 1 electron is gained by the chlorine to form the chlorine minus ion. So obviously the electronic configuration will be become electronic configuration will become 1s2, 2s2, 2p6, 3s2, 3p6, which will be the electronic configuration of nearest stable inert gas, that is argon. Clear? So the same explanation is given in terms of words here. The 7 valence electrons, chlorine gains 1 electron lost by the sodium atom to achieve the stable electronic configuration of argon, forming a chloride minus ion. Then last, these Na plus and Cl minus ions are forming, right? From the sodium they are forming the cations, from the chlorine they are forming the anions. So these chlorine, these Na plus and Cl minus are combined together to form the NaCl or the ionic compound here. Is there any doubt? This is the sodium chloride, right? Okay, same it is repeated here. Sodium atom, chlorine atom to form sodium ion plus chlorine ion to form the sodium chloride. Now let us see what are the characteristic properties, right? Characteristic properties for the or condition that is favorable for the high Durgeshwar, favorable conditions favor for the formation of ionic bond, right? We have already seen in the case of covalent bonds. Now we need to talk in the case of ionic bond, right? So as we already know, it should be formed between a metal and a non-metal, right? Metal and a non-metal. So transfer of electrons takes place from the metal atom to the non-metal atom. For example, if you are taking in the case of sodium chloride, electron will be transferred from sodium to chlorine. Clear? So this is the first condition. And the second condition, in the formation of an ionic bond, there must be an overall decrease in the energy. Energy will be always decreased. This is one more point you have to keep in mind, that this means energy is already released there. Clear? A bond is formed there by the transfer of electrons. Obviously, there will be energy release happens, right? Which means energy is always released or decreased. Then, if you are talking in terms of the complete periodic table, we have already studied, right? Alkali, metals and halogens. So what do you mean by alkali metals? Group 1 elements, right? Group 1 elements. So group 1 elements are known as the alkali metals, and halogens means they are the group 17 elements. We have already studied the classification of elements of periodicity and property in detail. So the strongest ionic bond is formed between alkali metals and halogens, right? Alkali metals and halogens. Okay, here the transfer of electrons are happening, right? That's why energy is released. Energy is decreases. Energy is always released with that. That's why their energy is decreasing here in terms of ionic compound. Okay, then the strongest ionic bond is formed between cesium and fluorine, right? Cesium, as we already know, this is a group 1 element or the alkali metal, right? Then fluorine is the another element, that is halogens. So if there are any question based on the term that which one is the element which is forming the strongest ionic bond, it is between cesium and fluorine, right? Cesium and fluorine. Cesium is the alkali metal and fluorine is the halogens. Then again, generally the oxides, halides and sulfides of alkali and alkaline earth metals are ionic in nature. So based on the sentence, you can get the question like that if you need to identify the which one among the following are the ionic compounds. So if they are containing oxides, halides and sulfides of alkali metal means group 1 elements, right? Lithium, sodium, potassium, rubidium, cesium. Then group 2 elements are known as the alkaline earth metals. Okay, I hope you understand the sentence, right? Is there any doubt? These are the points you have to keep in mind, that based on the particular sentence, you will be getting the application level question. You need to identify the ionic compounds from the given options. So you can easily identify that if they are the oxides or sulfides, or halides or the alkali metals or alkaline earth metals, it will be easily formed the ionic bonds. Is that clear? Now let us talk about the physical properties of the ionic compounds. Okay, what do you mean by halides? Those who are containing the halogens, right? So sodium chloride is an example of the halide, sodium chloride, right? Chlorine is the halogen compound. They are forming the halide or the chloride. So this is the sodium is the alkali metal compound, right? So if you are containing the halide of alkali metal, obviously they are the ionic compound. Is that clear, Arush? We have already seen the formation of NaCl by using Na plus and Cl minus. Okay, fine. Okay, now let's talk about the characteristic properties of the ionic compounds or the ionic bonds. So first one, physical state. I hope you can see the image clearly here. There is a particular structured arrangement or the ordered arrangement of atoms, right? So this such type of arrangement is known as the crystalline solid. So these ionic compounds are crystalline solids at room temperature. Clear? The well-ordered arrangement of atoms is known as the crystalline particle or crystalline solid. So all the ionic compounds, including NaCl or MgF or something, they are crystalline solids at room temperature. This is about the physical state. Now let us talk about the melting point and boiling point. So what about the case of melting point and boiling point in the case of covalent compounds? We have discussed in the last class. Whether it is very high or low. In the case of covalent compounds, they will be having very low melting and boiling point, right? But in the case of ionic compounds, they will be having high melting and boiling point because of their force of attraction. So here, in terms of value, they are given for the ionic compounds like the sodium chloride. They will be having the ionic charges 1 plus and 1 minus. So melting point is 801 degrees Celsius, and boiling point is 1.13 degrees Celsius, right? Then if you are taking the magnesium oxide, right, MgO2, magnesium oxide, they will be having, so just try the home as an homework how magnesium oxide is forming, right? Magnesium is losing 2 electrons to form the Mg2 plus ion, and oxygen is accepting 2 electrons from the magnesium to form the O2 minus ion. So they are forming MgO, right? MgO will be the chemical formula of magnesium oxide. So their melting point is 2852 and boiling point is 3600, right? Which means that they will be having high melting and boiling point because of this strong force of attraction. Clear? Another property is about their hardness and brittleness, right? Ionic compounds are hard in nature. Their hardness is due to the strong force of attraction between the oppositely charged ions which keep them in their allotted positions, right? I hope you understand. The case of ionic compounds, they are formed by the formation of cations and anions, right? So the opposite attracts obviously. So these charged ions will be having the strong force of attraction between them. That's why they are very hard. But in the case of covalent compounds, they are neither hard nor brittle. Clear? So when you are studying about the ionic compounds and covalent compounds together, you must have a clear idea about the difference between covalent compounds and the ionic compounds, either in physical state, conductivity, or brittleness or hardness also. Just for a representation, they are giving the images here, which means that ionic compounds are always hard in nature because of their strong force of attraction. Now, the next point is based on the density. So, what will be the density for the ionic compounds? Hi, Piyush. They are always heavier than water, right? Heavier than water means they will be having a high density. Density, as we already know, mass by volume, right? So, if they are heavier than the water, obviously they will be having the high density, right? Yes, greater than 0. Then we need to talk about the solubility in water. Ionic compounds are generally soluble in water but insoluble in organic solvents, right? Insoluble in organic solvents. So we have already studied in terms of, hi Farhan. So we have already studied in terms of the covalent compounds about their solubility, right? Polar solvents always dissolve in the polar compounds dissolve in the polar solvents, and non-polar compounds dissolve in the non-polar compounds. That is known as the like dissolves like, right? Like dissolves like. So ionic compounds are polar compounds. So they are soluble in the polar solvent like water. Is that clear? A common example is given here. This is our common salt of NaCl, right? So if you are adding sodium chloride to the water, obviously it will be getting the saline water, right? It is dissolved in the water to form the sodium chloride water or the saline water. Clear? Okay, organic solvent we have already studied, right? Benzene. Yesterday we have already studied the case of organic solvents. Covalent compounds are already soluble in the organic solvents like ether or benzene. Durgeshwar. Then what will be the conductivity of electricity or conductance of electricity? Whether they are able to conduct electricity or not. So in the case of ionic compounds, as we already know, they are crystalline solids. There is a well structured order of the atoms present there. There is any possibility of movement of ions. So in the solid state, these ionic compounds are not conducting electricity. Or we can say that solid ionic compounds are poor conductors of electricity because the ions are fixed rigidly in their position, right? Fixed rigidly in their positions. But if you are dissolving into the water molecule, if they are forming the aqueous solution or the molten state, if you are melting the particular ionic compound, there will be chances of movement of free ions, right? These cations and anions will be start to move from here. So they will be conducting electricity. Is that clear? There will be good conductor due to the free ions. Okay, I hope you understand. So these are the many important properties regarding the ionic compounds. So that's all about for the ionic bonds and the ionic compounds. We have started from the basic definition for the ionic bonds, right? So what is the basic definition for the ionic bonds? They are the electrostatic force of attraction, which is formed by the transfer of electrons between metals or non-metals, right? So most common example is the sodium chloride Na. Generally, metal will be having the electropositive character. They will be easily lost the electrons to form the cations, and these electrons are gained by the non-metals. Non-metals will be having the tendency to gain electrons, right? So they will be forming the negative ions or the anions. So these cations and anions combine together to form the ionic compounds by the strong electrostatic force of attraction. Such bonds are known as the ionic bonds. Clear? Then what is the condition for the formation of ionic bonds? We have already seen. We have seen the characteristic properties of the ionic compounds by physical state. They are the crystalline solids, right? And they have high density. They will be conductors in terms of solution state or the molten state or the aqueous state. When they are hard, right? They are hard and brittle. Is that clear? Now let us practice some questions which we have discussed in this class. Very basic questions. We need to just revise the topic. So here is the first question. Which of the following best describes an ionic bond? Yes, option B, right? I have already repeated many times. It is the bond formed by the transfer of electrons between metals and non-metals. Durgeshwar, what about this bond? Option A, bond formed by the sharing of electrons. It is our covalent bond, right? We have discussed in the last class, yesterday's class. Clear? Yes. So here question is asking about the terms of ionic bond. So option B will be the correct answer. Now we are moving to the next question. Ionic bonds typically forms between. They are just giving me a random options to confuse you. There is nothing meaning about the option C and D in terms of bonds. So here is the next question. Ionic bonds typically form between two non-metals, two metals, a metal and non-metal, or a metalloid and a non-metal. Yes, again option B, right? A metal and non-metal. Most common example is the sodium chloride. Sodium is the metal and chlorine is the non-metal. Here is the next question. Which of the following compounds is an ionic compound? Yes, sodium chloride, right? So instead of sodium chloride, if they are giving any MgO, magnesium oxide or any other compound, you will be getting an idea that will be the ionic compounds. They are formed by the transfer of electrons, right? If you are comparing H2, as we already know, the electrons are shared by the atoms here, right? Between hydrogen and oxygen. Again, the carbon dioxide and CH4 also, they are formed by the sharing of electrons of the covalent compounds. Now we are moving to the next question. The force responsible for the ionic bond is? Yes, option C, right? Electrostatic force of attraction between the positive and negatively charged ions is responsible for the ionic bond. Okay. We have already seen the very basic questions based on the topic we have studied in today's class. We have already seen the simple topic about the formation of ionic bond, right? How ionic bond is formed, how the ionic compounds are forming. So far we have discussed the basic introduction part about the chemical bonding. Then we have seen the formation of covalent bond. Then today we have covered the formation of ionic bond, right? The next class I am going to dealing with the next part of the chemical bonding. We will be dealing with the valence bond theory, hybridization part, and the previous year questions for the chemical bonding and molecular structure chapter. Okay, I hope you understand the lecture today. Do you have any doubt you can ask? Otherwise, we can wind up the session for today. Again, there is a gentle reminder about the SCORE examinations. Sri Chaitanya Academy is giving an opportunity for the international level scholarship exam, as we already know. The exam will be conducting on September 28 and October 12, already in online as well as the offline mode, right? So exam will be conducted on October 12 and September 28. You need to register before September 26 for the examination. You will be getting the NASA trips, exciting gadgets, and 100% scholarship by the Sri Chaitanya Academy. So this opportunity is available for the students from grade 3 to 11. So you can register now. The link will be provided in the description. Just register now for the examination, attend the examination. It is a great opportunity for you. Don't miss the opportunity. Okay, Radhika, I think all the details are provided in the brochure given in our website. You can just refer there. Regarding fees and the centers, offline centers are also available there. Arush, you will get a proper idea about the molecular structure when we are moving towards the end of the chapter, right? Chemical bonding is a vast chapter, a very big chapter, which we are dealing detail about the grade 11 classes. But I will be just giving a brief idea about the complete chapter. Then you will get an idea. Durgesh, I didn't get your question. Non-metal react with water and acid, right? Okay, we have already completed the chapter, right? Metals and non-metals. You can just refer from there. Okay, I hope you guys enjoyed the session. If you really like the session, hit the like button, share this particular session to your friends also. It will be really helpful for them also. Then subscribe our channel, Infinity Learn 9 and 10 YouTube channel. We want to get the session PDF. You need to join our Telegram channel, Infinity Learn 9 and 10 Telegram channel. You will be getting all the session PDF after all the classes there. Durgesh, we have already covered the chapter twice, right? I have already completed the revision part also. That's why I'm not repeating again. Just rewatch the recorded session for the metals and non-metals. If not clear, let us discuss in next class also. Fine? Okay, then thank you so much all of you. See you in the next class. Bye-bye.